Hello friends, so let's start with problem number 1, which is based on evaluation of integral over the given region. So guys, here we will be having function and we have to integrate, or I would say double integrate this given function with respect to some variable, and here will be given the curves. So what we have to do is we have to draw the curves and get that common region, and for that we have to find out the limits and evaluate the integration. So let's see how to solve such type of examples. So now here we have double integral xy dx dy over the region R, where R is the region bounded by the parabolas y square equal to 4ax and x square equal to 4ay. So guys, now it is straightforward given that these are the parabolas, but let me tell you that we have studied in 11th-12th standard that y square equal to 4ax is a standard equation of parabola opening towards right because x is positive. So how to identify this? So guys, always remember, in parabola you have one term as a square term and the other term as the power 1 term. So what you have to do is, since this x is a positive, so on the coordinate axis it will open towards the positive x side. Let's say tomorrow it is negative, then it will open towards the negative x side. Next, here we have x square equal to 4ay, so we'll never see the square term, we'll see this term. So this is positive y, so it will open upwards, and if it is negative y, it will open downwards. So you have to remember accordingly. So guys, if I have to evaluate this, then what we have to do is, the one thing is we have to draw these parabolas. We have to find out a common region because it is given that that region is bounded by the parabola. Now what does it mean? So whatever is our region, it should be covered or the bounded by this given curves. So the boundaries of that region must be this curves. So we'll find out that region, and from that region we'll find out the limits, and then we'll evaluate the integral. So let's start. So what I'll do is, here I'll draw the curve. Now guys, this is the parabola opening towards right. So guys, here I've drawn both the parabolas. So remember, in exam you have to draw these curves as a freehand drawing. Now if you will see this, then this is a region which is bounded by two parabolas. So this side of the region, or this boundary of the region, is a parabola y square equal to 4ax, and this boundary of a region is x square equal to 4ay. Now guys, we have to integrate this this given function over this region. So what we'll do, so we have studied in the first video that how to evaluate double integral. So in that I've shown you that whenever we have the region, we take a strip either parallel to x-axis or parallel to y-axis. So same thing I'll use here. So what we'll do here is, I will take a strip which is parallel to x-axis. So let's assume that this is that strip. Now guys, this strip, now we'll find out the endpoints of a strip. So the endpoint here, these are the two endpoints. So since the strip is parallel to x-axis, we'll find out the endpoints in terms of x. So x equal to, let's see what we get. So this is a curve which is x square equal to 4ay. So if I find x, so x will be root on both sides, so 2 root of ay. So 2 square root of ay. Similarly, this point or this end of a strip lies on the curve y square equal to 4ax. So from here we'll get x as y square by 4a. So here I'll write x is equal to y square upon 4a. Now guys, this strip will move over the region, so it will move horizontally, so that it will cover the whole region. So remember that this strip is a flexible strip. So just imagine that this strip is moving vertically and it is covering all the region. So it is going from this part to this part. So what we have to do is, when this strip will move vertically, we have to observe the end points of the region. So let's say if this strip is going upwards, then what is the last point where it will go? And if it is going downwards, what is the last point it will go? So this strip, if it is going upwards, then it will go till this point, and when it is coming downwards, it will come till this point, because this is what are the boundaries of our region. So we are not going to consider the points which are outside the region. So this is a point, these two are the points where our strip will reach, or these are the end points of our region. So what we'll do is, guys, we'll find out the coordinates of these points. Now if you'll observe, then these 2 points are the points of intersection of these 2 parabolas. So guys, we have to find out the point of intersection for these 2 parabola. Now the question is, how do we find out the point of intersection? So it's simple. We substitute equation of one curve in other curve to get the point of intersection. So here we have y square equal to 4ax. So from here we'll get x as y square by 4a. I'll put that value of x in this curve. So we will get x, that is y square by 4a, and here we have x square, so I'll do the square, is equal to 4ay. So what I did is, I have substituted value of x from this curve in the second curve. Now let's solve this. So here we'll get y raised to 4. In denominator we'll get 16a square, which will go on the right hand side, and it will multiply this 4a. So 16a square into 4a is 64a cube into y. Now we'll take it on the left hand side. We'll get y raised to 4 minus 64a cube y is equal to 0. Now guys, we'll take y common. So we'll get y cube minus 64a cube is equal to 0. Now guys, what happens in this case, I'll tell you. The common mistake that is made by the students, what they do is, they take the 64a cube y on the RHS, they make it positive, and they cancel y and y. So it becomes y cube is equal to 64a cube. So guys, my suggestion is, do not cancel any variable, because we are trying to find out points of intersection. So try to find out maximum point of intersection. As you can see here that there are 2 points of intersection. So let's say if I take this on the right hand side, and if I cancel y and y, so we'll get y cube is equal to 64a cube, and therefore we'll get y equal to 4a. It means we'll get only 1 point of intersection. So if you want to get maximum point of intersection, then don't cancel y. So that is why what I did is, I have kept this 64a cube y on the left hand side, I have taken y common, and I got this equation. So from here we can say that therefore y is equal to 0, or y cube minus 64a cube is 0. So which is y cube is equal to 64a cube, and taking cube root on both sides will get y is equal to 4a. So guys, here we got 2 values of y, 0 and 4, and you can easily observe from here that at this point y is 0, and at this point y is 4a. So if y is 4a, let's find out the value of x. So I'll put this value of y in any of the curves. So if I put that value of y over here, so we'll get 0 equal to 4ax. So 4a will go here and x will be 0. So here I'll write, for y equal to 0, x is equal to 0. Next, if y is equal to 4a, if I put it here, we'll get 4a square, which is 16a square. 16a square upon 4a will be 4a. Therefore, x will be 4a. So guys, we'll get point of intersection as 0, 0 and 4a, 4a. So this is 0, 0, and this point is, here I'll write 4a, 4a. So it means our strip will move from 0 to 4a. So just imagine that this strip is moving vertically. So it will move from 0 to 4a. So guys, here I got the limits. So for x I got this limit, and for y I got 0 to 4a. Now guys, how to write this? So the normal convention is, whenever we have a strip which is horizontal, then take the limits from left to right, because you can see that when we are here, the value of x is less, and when we go to the RHS, the value of x increases. So go from lesser to higher. So how I'll write? So here I'll say I is equal to double integral x is equal to y square by 4a to 2 root of ay. So what I did is I took this as the lower limit and this one as the upper limit. Now as we have taken the x coordinate, now we'll take the y coordinate here. So here the y coordinate is 0, here it is 4a. So we'll say that y is changing from 0 to 4a. So guys, again observe one thing, that in the coordinate system the value of y increases as we go up on the y-axis. So that is why I always take value from down to up. So I have taken from 0 to 4a. So this is just a hint because many students get confused that should we take 4a to 0 or 0 to 4a. So these are the convention. Now as we have taken the x limits and y limits, so one more thing guys, since we are taking a strip which is parallel to x-axis, so what we will do is we'll integrate this integration with respect to x first. So rule is, if you are taking a strip parallel to x-axis, you have to integrate with respect to x first, or if you are taking a strip parallel to y-axis, then you should integrate with respect to y first. So I've already explained this in my first video of how to evaluate double integral. So if you have not revised it, then I would request you to go back and revise it once again. So let's move ahead. So guys, here the function is xy and here we'll write dx dy. Now why dx? The reason is we have taken a strip which is parallel to x-axis. Hence the integration will be with respect to x first and then with respect to y. So let's start. So since I am integrating with respect to x, y is constant. So here I'll write y is from 0 to 4a. I'll take this y outside and in the integration only x will remain. The integration of x is x square upon 2. Here I'll write it is x square by 2 and the limit is from y square by 4a till 2 root of ay dy. Next, this 2 in the denominator will take it outside. So 1 upon 2 outside. Integration 0 to 4a. Next, we'll put these limits in x square because we have already taken 1 by 2 outside. So if I put this, so square of this will be 4ay. So here we'll get 4ay. Then middle sign is minus and now we'll put the lower limit. If I substitute lower limit is this, the square of this, because this is a value of x. So square of this will be y raised to 4 upon 16a square. So that is the value into dy. So now this is the value that we got, and with this we also have one more y which we have taken outside. So I'll write down that y over here. So now guys, let's multiply this value with y and then let's integrate with respect to y. So here we'll get I equal to 1 by 2 integration 0 to 4a. Now when this y will multiply 4ay, will get 4a y square and here we'll get y to the power 5. So 4ay square minus y to the power 5 upon 16a square into dy. Now guys, we'll integrate these two terms. So we will get half 4a as it is, or it's a constant, we'll take it outside. For y square we'll get y cube upon 3 minus 1 upon 16a square is a constant. For y raised to 5 we'll get y raised to 6 upon 6 from 0 to 4a. Now let's substitute the upper and lower limit. So here we'll get half 4a upon 3 as it is. Here the 4a the whole cube. So 4a whole cube is 64a cube. 64a cube into 4a is 256, a to the power 4 upon 3. Here we have 1 upon 16a square. Now here we'll put this as 4a raised to 6. So here I'll write 4a raised to 6 upon 6. Next middle sign minus, and if we put 0, we'll get all terms as 0. So we'll not take it. Now guys, let's simplify this. So here we will get half in bracket. We will get 256a raised to 4 by 3 minus. Now here we can cancel a square and a square. So here we'll get a raised to 4. Next, 16 is 4 square. And in the numerator we have 4 raised to 6. So 4 square and 4 square cancel. So 4 raised to 4 will remain in the numerator. So 4 raised to 4 is 256 upon 6 as it is. Next, here we can take 256 common outside, a raised to 4 outside and 3 outside. So we will get 256 a raised to 4 upon 3 outside. So 256 a raised to 4 upon 3, and already we have 2. So 3 into 2 is 6. Now let's see what remains in bracket. So from here 1 will remain minus, from here 1 upon 2 will remain, because we have taken 1 upon 3 outside. Now guys, let's simplify this. So here I'll divide these two numbers by 2. So we will get 128 a raised to 4 upon 3, and this will be 1 by 2. And in the end we will get 64 a raised to 4 upon 3. So therefore the value of integration is 64 a raised to 4 upon 3. So guys, here we have evaluated this integration over the given region. So I'm sure you understood how I've taken the curve, how I've taken the limits, and how we got the solution for the integral. So guys, just follow this step and you can get the answer in the examination. Thank you very much for watching the videos.